Okay, good evening guys. It's Navi joining the call. Can you guys hear me? Could you please type in the chat window if you can hear me fine? Thank you guys. Just give me one moment. There you go. Okay. So today we'll have a touch of what is natural language processing, and we'll try to kind of get a feel of real world case study guys. Yesterday we briefly discussed about text mining, and there's a subtle difference between the natural language processing and the text mining guys. Text mining is based on what you observe. Being able to identify the patterns and things like that is what is text mining. Whereas natural language processing is an automated way to understand and analyze natural human languages and extract the information from such data by applying machine learning algorithms, which is slightly close to the definition of text mining, but more precisely, natural language processing is based on features which are not observed. It will try to understand the context is what it will really try to do, and which is what we'll try to understand guys. Why natural language processing? Analyzing tons of data. Today we have a lot of data, especially the textual data and things like that. That is what constitutes 80 to 90% of the data in the world, which is called unstructured data. We have data in various languages, dialects, and what we need to do is we need to convert this textual data into numerical data, which is referred as quantitative analysis. We need to handle the ambiguities. Ambiguities is the inconsistencies or the problems in the textual data is what is an ambiguity, guys. Okay. In general, what we do in natural language processing is these are some of the high-level steps: tokenizing, stemming, TF-IDF. These are some of the stuff that we discussed yesterday, and semantic analysis, which involves understanding the parts of speech, disambiguation, topic modeling, word boundaries. These are generally the high-level steps that we perform in a natural language processing, guys. Okay, so if we go a little bit deep, we are taking the textual data. We are trying to identify the words and the tags, the parts of speech tags. We can classify the text, and we try to extract the information, analyze the sentences, build features. Features are nothing but the words. The words become your features. Features are nothing but the independent variables or the columns. And then we try to understand the meaning, which is nothing but the context. So, for example, imagine one of you guys is chatting with your friend and saying, "Hey, I'm traveling to Paris." The context there could become the travel, or the context there could become French. Imagine one of you is typing a message. So what is it? You're not referring to French, but the context is becoming the French, guys. Okay. So these are some of the major NLP libraries. NLTK is one of the major libraries. Scikit-learn is also a library, but generally Scikit-learn is not used that popularly for natural language processing. We either use NLTK. NLTK is slightly low level. TextBlog and Spacey are heavily used in real world. These are slightly higher level libraries, guys. Okay, but we'll try to look at a touch of NLTK because we need to understand certain low level concepts and things like that. A data object in a natural language processing world contains these three sections: a bunch, a target name, and data. Bunch is nothing but contains fields and can be accessed as dictionary keys, or an object. In other words, that is nothing but the independent variables. Target names is nothing but the dependent variable, and data together constitute the bunch, and the target names really together constitute the data, guys. Okay, so again, this might be a slightly confusing at this level, but when I actually show you an example, you may be able to better follow it. But from a feature point of view, but from a literature standpoint of view, I'm just introducing, guys. Feature extraction is a technique to convert the content into numerical vectors. Yesterday, when we looked at the TF-IDF principles, we have seen how we are converting the textual data into numerical data, guys. So we are taking the steps of TF-IDF, we convert them into vectors, and we represent them in a Cartesian coordinate system. And then we are using the cosine similarity. We're converting textual data into numerical data. So when we convert them into numerical data, what is happening is we can then use them for the machine learning algorithms. Okay, so what is text feature extraction? It is nothing but trying to understand the important features in the textual data. It becomes a text feature extraction. Similar kind of concepts can also be applied for image feature, but we'll not worry about the images right now, guys. Generally, these are the steps that we follow. When we have certain documents, what we do is the first step is you You take all the documents, you take each word. The token here is nothing but a word. You try to count in each word or each token how many times it's appearing in a document. You prepare a table. This is generally referred as bag of words. It's nothing but a group of words in all the documents, how many times they're appearing. And all these documents together is referred as a corpus, guys. So for that, what we do is we tokenize. We separate all the words, then we count it and we store it. That storage is this table. This is referred as bag of words. Then model training. Then there are two kinds of machine learning, supervised and unsupervised. We have discussed them in detail in the earlier days. Supervised is where we have dependent variable. There are a group of algorithms which support the supervised machine learning. There are a group of algorithms which support the unsupervised. So supervised is where we have a dependent variable and we partition the data, we train the data. In unsupervised, we just try to find the hidden patterns and things like that. Clustering, association, K-means clustering and association rules finding are examples of unsupervised learning that we discussed earlier, guys. Okay, supervised is, here are some examples. We looked at linear regression. We did not really get a chance. We also looked at logistic regression. Today I will give you a brief introduction of Naives Bayes. Naives Bayes algorithm is by itself a book itself, but for the sake of, I'll give you a high level look and a touch of it so that we have an idea. That is also a supervised machine learning algorithm, guys. So here comes Naives Bayes classifier. It is similar to logistic regression. It predicts what is textual data. Remember, if you want to predict the score of a player, it is a numerical data. But if you want to predict if India is going to win or not, that is textual data. That is what is Naives Bayes classifier, guys. So let's see, the advantages of Naives Bayes classifier is it is efficient as it uses limited CPU and memory. So in other words, it's sorry about that. It is okay. In short and sweet, it is just efficient, guys. Why it is efficient, we'll try to understand once we have a mathematical understanding of some of the concepts. It is fast as the model training takes less time. So in other words, it takes less time compared to the their algorithms. Users Naives Bayes is used for sentimental analysis, email spam detection, categorization of the documents, and language detection. All these are natural language processing case studies, or generally these are the kind of projects that we get involved in natural language processing, guys. Multinomial Naives Bayes is used when multiple occurrences of the words matter. In classification, we have something called binary classification and multinomial. Binary is when we have two choices, yes or no. But if you have more than two choices, imagine if you have two choices, India is playing against Australia tomorrow. The two choices are win or lose. But imagine we introduce a third choice, which is draw. Then what is that? In that case, it is not binary, it is multinomial. So we can also build a model for multinomial, which is nothing but having more than two choices, guys. So at a high level, let's try to understand what is Bayes theorem. In order to understand Naives Bayes classification, we need to have a understanding of Bayes theorem, guys. So let's see what that means. So here is Bayes theorem. This is a simplistic explanation. Probability of an event is between 0 and 1. Probability is always between 0 and 1, back to school, if you recall. Bayes theorem gives a conditional probability of an event A given event B has already occurred. Okay, so what does that mean? So here is slightly at a mathematical level. We read this as probability of A given B. And that is probability of A intersection B multiplied by probability of A divided by probability of B. Okay, that is at a mathematical level, guys. Okay, so imagine, let's take this one. There are 100 patients. Imagine we have 100 patients. Probability of a patient having diabetes is 0.2. Means 20 patients out of 100 patients have diabetes. Is what is the meaning of that. Now, probability of a patient having diabetes, given that patient's age is greater than 50, is 0.4. Is represented like this. Probability of A is probability of patient having diabetes. Given B, what is B? Given his age is greater than 50 is 0.4, means if you take 20 patients out of 100 patients, 0.4 of those 20 patients will be 5. 5 patients' age is greater than 50 is what is the meaning of it. So what is that? That is referred as conditional probability. Bayes' theorem works on the principles of conditional probability. So in other words, another example is, imagine there is a cricket match with Australia tomorrow. Imagine there is a possibility that India has, let's say, 60% chances of winning against Australia. But by evening you come to know that Virat is not playing the game. So what happens is, the probability of India winning a game reduces from 60% to 50% for the sake of simplicity. What is happening? As we add a condition, as we take a condition into consideration, the probability is changing. What is that? That is conditional probability. Okay, so in other words, that is exactly what is going on. 20% of 100 is 20 patients have diabetes, and out of those 20 patients, what is happening? 40% of them, what we are observing is their age is greater than 50. So what is this one? This is acting. The age is greater than 50 is acting like a condition, and what's happening? The probability is now changing. What is that? That is conditional probability. We can go ahead and add more conditions, and there will be more change. What is that? At a slightly high level, that is what the Bayes theorem. So what is this? This is what the Bayes theorem is, works on the principles of conditional probability is. Okay. So what is Naives Bayes classification? Classification is, again, if you want to predict a textual data, a binary, yes or no, and things like that, we call that kind of machine learning, that kind of model is referred as a classifier. Application of Bayes theorem to machine learning means we are applying Bayes theorem in the world of machine learning, that is referred as Naives Bayes classification. Okay, why? What is naive? Naive means something innocent. The target variable becomes a event A. What is the target variable? The target variable is a dependent variable. That's another terminology, guys. The predictors are nothing but the independent variables. A dependent variable is dependent on many other independent variables. Here, the predictors can be many conditions. So what do? We try to find probability of A given many conditions B1 to Bn. So here is another example. Let's see. Here is a patient whose age is 24 years old. 24 years. His body mass index is 22. He is not diabetic. Probability of he is diabetic given that age is 24 or 22. Okay, so in other words, he is not diabetic. And here is another patient whose age is 41 and his body mass index is 36. It's more. His age and body mass index is more. And what is this? Well, he is diabetic. Ideally, what we'll do, we'll take tens and tens of such patients. We'll give it to an algorithm that will give us a model. Okay, what will it do internally? Let's go one step ahead and see some of the principles of it, guys. So we'll take another example for the sake of simplicity. Model building and prediction. The model generated stores the conditional probability of the target, which is nothing but the dependent variable, for every possible value of the predictor. What that means is, here is a table. Imagine a company, there are 200 employees in a company. What is happening is, we have their age, we have their gender, and we have their salary. What are we going to do? We have taken these three columns of data. Now what we are observing is, the overall probability is 0.75. What is that? The 75% probability, the salary is less than 50K. In other words, more precisely, imagine we have 200 employees in a company and 75% of the company's employee salary is less than 50K. 25% of the companies make more than 50K. Okay, what is this? This is called overall probability. Okay, this is about salary. The salary can depend on age. The salary can depend on gender. For the sake of simplicity, salaries are dependent variable. Now, let's do a little bit of cleanup. Take a look at this. Come to age. 1 to 20 is 0.1. So what is this 0.1 is? There is, if you take 200 employees and 10% of 200 employees, what are they? Their age is between 1 to 20 years, which is maybe generally minimum wage will be 18 to 20 is what it is. Okay, 30% of them are between 20 to 30, 30 to 25% are between 30 to 40, and so on. What is this? This is the probability of the age. How many people? Based on how many people are in what age range and things like. Then come to the gender. 39% of the company's employees are females, and 61% of the employees are male. That is what these represent, guys. Okay. Now, to clean up, let's come here. Take a look at this one. What is this one? This is 0.08. What is this one? This is, okay, my bad, guys. Okay, I'm going to, I think I stated it slightly differently. Actually, you ignore this table for a moment and take a look at this one, the overall probability. The overall probability is 0.08, means 8% of the employees are between age 1 to 20. 24% of the employees are between the age 20 to 30, and so on. This is all the age. 33% of the overall employees are female. 67% of the employees are male. Okay, what is this one? This is a table of probabilities. Now come down here. What this 0.1 is indicating is 10% of the employees are between the age 1 to 20 and their salary is less than 50k. In other words, there are two things going on here. What is that? Each one is acting like condition. What is that? That is conditional probability. What is this one? Next come to 0.3. So come back here. 0.3, there are 30% of the companies whose age is between 20 to 30 and making less than 50k. And what's happening? Come here. 39% of the 39% of the employees are female and their salary is between less than 50k. Okay, what is happening is we took 200 employees, and what is happening is we are coming up on this kind of probabilities. Who comes kind of probabilities? That is what it is. Space algorithm, a model. It is an algorithm which is building this kind of table with different kinds of probabilities, guys. Okay, so now a new prediction needs to be done. The conditional probabilities are applied using Bayes formula, which means imagine a new employee is joining, his age is 25. Now what the model or the algorithm is going to do is it will try to make a prediction that the salary, if his age is 25, what is the probability his salary less than 50k? Okay, what is it going to do? First it is going to pick up 0.3. Okay, or in other words, first we'll pick up the overall probabilities. 0.75 is coming from here. This is telling you 75% of the employees are making a salary of less than 50k. That will become probability of A. 24%, which is here. Do a little bit of cleanup. So 75% is coming from here. 24% is coming from here. This is overall probability of B, means the 24% of the employees, okay, their age is between 20 and 30. That is overall probability. Then come to 0.3, which is this one. This is a combination of both of them. In other words, it is saying 30% of the companies are between, employees are between 20 to 30 and their salary is less than 50k. That is coming up here. This is probability of A, this is probability of B. We say this is probability of A given condition B is 0.3. It's a condition. 30% of them are satisfying this condition. They're also satisfying this condition, which is A and B. What is that? Because it's acting like a condition, it is referred as conditional probability. That is what is Bayes formula. So what is, if we apply this one, we get 0.92, which is 92%. Which means now the model is going to come back and say the probability that his salary, he or she, the salary will be less than 50k is 92%. Okay, what is the probability that their salary will be greater than 50k? Using the above principles, it will be percent. Is what 92% is less and 8%. So what is happening? This is how the Bayes algorithm works. It builds a table. When you give the data, it builds a table of this probabilities. Everybody getting an idea? I'm not expecting you to be perfect, but are you getting an idea? Okay, so really what I'm trying to convey is that the hard part of it is being done by the algorithm. It is, if you are slightly familiar, if you are slightly able to recall some of the principles of probabilities, this is the table of probability. It is building behind the scenes, guys. Okay, so now come here. Bayes at a slightly high level. These are some of the advantages and disadvantages. It is simple and fast. So we have just discussed it works based on table of probabilities. All it is using is the principles of probabilities. It works well with noisy and missing data. Noisy and missing data means even if you have some missing data, it ends up working well compared to the other algorithms. Although when we have missing data, we generally do the data cleaning, guys. It provides probabilities of the results. In other words, it's using the principles of probabilities. It is very good with categorical data, especially when we have a lot of columns which are categorical, which is textual data. Everybody looks at Nave's Bayes compared to the others. The shortcomings, limited accuracy. This happens with any algorithm. If we want to improve the accuracy, we should try to we should try to clean the data, and we should try to do feature engineering and techniques like that. And it expects predictors to be independent. So it is referred as naive. Naive means innocent. Innocent means this is the way when we have multiple columns of data, it is taking it for granted that one variable is not dependent on the other independent variable. That is why it is called Nave's Bayes. It is not good with numeric features, large numeric features. In other words, when you have all numeric data, generally you use Nave's Bayes when you have a lot of textual columns rather than numerical columns. It's used in medical diagnosis, used in spam filtering. Medical diagnosis is, somebody has a disease, does not have disease. Spam filtering is an email a spam or not a spam. Document classification, to which document, what type of document it belongs to, categorizing it and things like that. That is what is Nave's Bayes, guys. Okay, before I give you a touch of Nave's Bayes and things like that, let me quickly explain you what is also another concept of natural language processing, which is summarization. Okay, there are multiple approaches, a simple NLP approach and a deep NLP approach. So take a look at this, guys. We'll start with a simple approach. Thank you all so very much. Thank you to the Academy. Thank you to all of you in this room. I have to congratulate the other incredible nominees this year. The Revenant was the product of the tireless efforts of an unbelievable cast and crew. What is this one, guys? This is nothing but in an Oscar award ceremony, the producer or maybe the hero came to receive the award, and then delivered this speech, thank you speech and things like that, guys. So now what we are going to do is here, what we are doing is we are taking each sentence here, separating them into multiple sentences. So there are about 5 sentences. Here what we are doing is we are converting everything to lowercase. Okay, then what we are doing is we are kind of building a bag of words. What this is doing is it is taking each word and counting how many times it's appearing. And what is special about the word the is appearing 5 times. And what is that? That is the highest number. Compared to any other word, the word the is the highest number. Now, what do? You take the highest number and you divide by everything. What you get is a weight. Okay, so what from a bag of words we converted into a weighted table. Then take each line or each sentence. Thank you also very much means if you add up all these things, it gets a total of 2.3. That is for the first line. But we have multiple lines. What do? For each line, what you do is you calculate the score, weighted score. Then what you do is you sort them in a descending order. Now take a look at the top 2. These are the top 2 sorted after the weighted scores. So what is this? The Revenant was the product of the tireless efforts of an unbelievable cast and crew. Thank you to all of you in this room. What is that? That is what is called summarization. This is a touch of summarization technique in natural language processing. Getting an idea, guys? Quick yes, please. The same method, I see. Okay, interesting. Okay, so let's go one step ahead. Let's also take a look at a slightly deep learning. We have not talked much about deep learning method, but let's talk about another advanced concept called word to vector, guys. Okay, generally semantic information of the words is not stored. When we use bag of words or TF-IDF, the concepts that we discussed yesterday, when these concepts are used, what happens is semantic information. Okay, which means semantic means there is some hidden meaning in the textual data that is not being identified. Even in TF-IDF model, we only give more importance to the uncommon words. Okay, yesterday we discussed about the TF-IDF principles. Even that one is not does not really work well for many scenarios, guys. Okay, there's a chance of overfitting the model. If you recall, overfitting is when the model works well on the training data but does not work well on the testing data. Overfitting a scenario when model performs very well. Okay, that is the definition I just explained here. So stick with me, guys. Yeah, I might be confusing some of you here, but stick with me for a moment. In this model, each word is represented as a vector of 32 or more dimensions instead of a single number. In other words, what it means is, if you go back to the bag of words, this is what we are calling as bag of words. Each word, how many times it's appearing. So when you take a word and you represent it as the count of it, what is it here? We're representing it in one dimension. Each word we're representing it in one dimension. But word to vector is a concept where we try to represent each word in 32 dimensions. Relation between the different words is preserved. What does that mean? King and queen. What is king and queen? King and queen, and here is life. Okay, king and queen together make a life, is what we can say. King and queen are together. Okay, there is a saying in English, if you want to judge a person, you can look at his friends. Based on the friends, you can judge a person if he's a good guy, bad guy, or neutral guy, and things like that. Right, guys? So based on a group of words and their neighbors, you can judge what kind of a word, and you can come up with some insights is what is the meaning of that. King minus man plus woman is queen. What is king to a queen is man to a woman. You can kind of compare it like that. King to a queen is man to a woman. Okay, and what is special? Man and woman together make life. King and queen together make a life. So what is this? This is what at a mathematical level in a Cartesian coordinate system the vectors are indicating. They're putting the words together. And what can we do? We can identify the similarities between them. Okay, Sachin Tendulkar is the Roger Federer of the cricket. Roger Federer minus tennis plus cricket is Sachin Tendulkar means that is what word to vector will give you. Okay, word to vector will identify a relationship that Roger Federer minus tennis plus cricket equals to Sachin Tendulkar. What is the meaning of that? That Sachin Tendulkar, what is Roger Federer is to tennis is Sachin Tendulkar to cricket. What is this? This is called word to vector. Word to vector is nothing but a deep learning technique which identifies. So what is this? This is semantic information. This is the semantic meaning. The word to vector will just put the words together and it will just give us the mathematical this thing saying that hey, this is close, this is similar. What do? We make sense out of that. Sachin Tendulkar is the Roger Federer of the cricket, guys. Okay, so let's go one step ahead. Scrape through a huge data set like Wikipedia, split the word. So what that means is, take a look at this. Let's see if I can give you a quick touch of word to vector. Imagine we have 3 sentences where it is saying it is going to rain today. Today I'm not going outside. I'm going to watch the season premiere. Okay, these are 3 lines, 3 sentences. What are we going to do? Imagine we put the words in the form of rows and columns and going and going. Notice there's a 3 coming up here. Why? If you go back, going is appearing in the first line, going is appearing in the second line, going is appearing in the third line. So what do? We put a 3. Going and to together. Okay, so what do? Come here. Going to, going is appearing, going to. So going and to is appearing 2 times, so we put a 2. Like that we'll complete this table. Okay, how many times each one is appearing together and things like that, guys. Okay, so now what are we doing, guys? Notice here, the word going, right now, we have converted it into multiple numbers. Each of these columns have become multiple dimensions. What is that? That is word to vector. In TF-IDF, generally we represent each word in 1 or 2 dimensions. More precisely, we represent it in 2 dimensions. Word to vector. What magic you do is up to you. What mathematical principles is you use is up to you. What we are doing is we are converting and representing the words in multiple dimensions. When you save it in multiple dimensions, suddenly you are able to explain that Roger Federer. What is Roger Federer to tennis is Sachin Tendulkar to cricket. Sachin Tendulkar is Roger Federer of the cricket. You're able to identify what is that. That is what word to vector does. Okay. So once it does, we represent it in this format. We can reduce it using some dimensionality reduction techniques. The snapshot of all these things can be further be reduced in 2 dimensions like that, and that will come out and show us that give us the information that Roger Federer minus tennis plus cricket equals to Sachin Tendulkar is what it is, guys. So that's a touch of a concept, guys, but let's get into slightly a real world example. Let's say what we hear. Build an application which will take the input It will take input the name of a person and tell or predict if the name is male or female, choosing the features which your algorithm will use to identify whether the person is male or female. Okay, so let's see how the principles build up here, and that will give you an idea, and we'll try to understand what is the use of that kind of an application, guys. So take a look at this. Here, the Jupyter. So here we go. Def gender features part 1. It is going to take a name. Once you take the name, it is going to convert it into a string, convert it into a lowercase, and then what we are doing is it is going to return a dictionary. There it is extracting the last letter as the key, and value is going to be that one. So let's go ahead and say gender features. We have defined the function. And here is Sam. So if you give Sam to it, notice it's saying last letter is the key, M is the last letter. Say Soumya. Last letter is A. What is that? That's what the function is doing. Okay, now come back here. Take a look at this. We'll do some imports here. Put a stemmer and all these things is what we have seen. Okay, now here comes a slightly deep one. Take a look at this. Here is a touch of list comprehension. Take a look at this. What we have is, what this list comprehension is doing is names. Names underscore sample dot words mail.txt. What this is doing is words of mail. When you say words of mail.txt, there is a file. When you install NLTK, this file is installed. In that, there are a group of names. Amir is a male, Aaron is a male, Abi, Abe, Abbott, Abdul, Abdullah, and so on. If you scroll down, these are all the names of the males. Andonis, Andreas, and scroll down a bit further. Esau, Ethan. And let's scroll down a little bit more. Hillary. Hillary is also a male. Hillel is a male. Scroll down further. I'm looking for some female. All the males are on the top. And that is still males. Let's scroll down a little bit. There is females. Anita, Angie, Angel, Angelia. And scroll down further down. Blondie, Danny. And let's see. So here are a group of female names. Zuana, Zuzana, Sasa, and things like that, guys. So in other words, more precisely, if you scroll up a little bit, on the left hand side, the touch of list comprehension, this is extracting all the names which are males from the file called mail.txt, and it is adding to a list object. What is happening? Every name is being taken from that file, and it is creating a tuple on the left hand side with the name, with the actual name, and putting saying that it's a male. Then on, if you move slightly towards right hand side, this is I have a touch of two list comprehensions going on here. This is extracting all the female names from this file. Okay, this for loop is extracting all the female names. It puts each female name and says male, female, 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 like that. And all these things are getting added to a list object, and all these names of males and females are getting finally added to one global list object, which is names. Everybody with me, guys? That's a slightly tough one, but are you catching it? Why are we choosing 32 dimensions? Okay, that's a good question. Somebody is asking word to vector why we are choosing 32 dimensions. Exact answer I don't know, but I think I'm sure, you know, at the time of testing the algorithm and things like that, there is something they have picked up, guys. I really don't know. That's a very good question. Even I will need to go back and check it. But generally what happens is you can increase the number of dimensions, and you can also try to make it more more sophisticated and things like that. That is generally what we have been dealing and things like that, guys. So I did not worry about why they have only chosen 32, but a very good question, guys. Tough question also. So now come back here. We have, what do we have? We have names, which is like a list object where we have, some of them are male and female. This is going to be our data. Now let's say come back here. Next step, what we are going to do is, it looks like all the names of the male are on the, and female are on the below. So what we'll do is we'll shuffle them. Once you shuffle them, shuffle the names, take a look at this one. We'll just check the first 20 names. Give me the name and the gender. We're using a for loop, and we'll print the name and the gender. There it is. So now, looks like all the females are coming up. Oh, okay. So if you, on a few of them are females, and then there is a male and a female, female and a male and female. So they're all shuffled. Generally, what we do is we don't have all the males on the top, females below, but we kind of have a mix and match of them. So that is what the shuffle is doing. It's taking all, I think there are close to 1,000 or maybe 10,000 of them, guys. So now what we are going to do, here's a slightly tough part which is coming up, guys. Take a look at this. Feature sets, gender features part, name.lower. I'm going to first run this one. Feature sets. And now what we'll do, let's take a look and see what is inside this feature set. What happened here? If you look at this one, what this is doing is, here is a for loop. It starts here. We are going to the names which contains, and take each name and gender. When you take each name and gender, from here it is passing on that name. It is converting it to lowercase, passing on that name to the function that we have written earlier. And what this is doing is, it is extracting the last letter. It is extracting, it's creating a dictionary on the left hand side. A dictionary on the left hand side, and saying, hey, here is the last letter, L, for a particular name, and it's recording the gender female. Then here is the next one. For the next name, last letter, whether it's a male or female. So if you scroll down, female, female, male, male, and so on. And what is it doing? It's sometimes certain names have the last letter as A, they're a female. Sometimes certain names have last letter as A, and there could be male also. Okay, it is not necessary all the females' names end with an A, all the males' names end with a B, or anything like that. It can be anything and so on, guys, based on the language and things like that. So what is it? We are building up something like this. Okay, this is textual data. This is also textual data. This is referred as categorical data. Now, let's go to the next step. What we will do is, if you look at these feature sets, this will give us the length. This means there are close to 8,000 names is what we have. In this list object, there are 8,000 of them. And now what we will do is, we are going to use this as our data. So in other words, more precisely, let's say come here. We're going to take this data. We're going to treat this as our independent variable. This is going to act like our independent variable, the predictor, and it is categorical column. Then this is going to act like our dependent variable. It is going to tell us who is a male versus female and things like that. And what is happening here? Sometimes, as I said, some letters who are ending with L are female. Sometimes the letters who are ending with an L may be a male also in the 8,000 names. So in other words, this is becoming the independent variables, which is what we refer the notation as X, and this one is becoming a Y, a small y. Okay, guys. So now let's come back here. We will take the X and Y. We are going to separate them into training set and testing set, which is we are going to partition the data into training and testing. Training set is feature sets of 3,000 till the end, means out of the 8,000 names, we are taking 5,000 names and putting it in the training set. So in other words, we are going to take 5,000 of these things. Let's say this is 5,000 of them, that's 70% or 80%. We're going to call this as training set. So if we come back here, let's see if we are able to visualize. Let's choose this one. How about this one? This is the training set is going to be this one, roughly 70%, 80% for sake of simplicity. And this is going to be the testing set. Training and testing, this is what is splitting, this is what is partitioning, this is what is supervised learning. Okay, and now let's come back here. What we are going to do is, we will take the training set, which is 70% or 80% of the data. We will give it to Naives Bayes classifier train. This is like the Naives Bayes classifier. This is like a fit. This is where we are giving the data, an algorithm. So let's say come down here. So which means if we come back here, This one. We are taking the 70% of the data, 70 to 80% of the data, we're going to give it to the algorithm. So let's say, here is the algorithm. What will the algorithm do? Well, let's say, come here. The algorithm is going to get rid of this one. For the sake of discipline, I'll use this as the algorithm. The algorithm is then going to build a model. This data, 70 to 80% is given. It is going to give us a model. Okay, now this model can be given. You give it a new name, it will tell you whether it is a male or a female. What is it doing? It is predicting whether somebody is a male or a female. Let's see how that works, guys. Let's say, come back here. So when you say train, that the math of Naives-based classifier is happening. What is happening is, it is a table of probabilities based on values like this. Behind what the algorithm is doing. The algorithm will take all these things. So this is male. So what does it do? It builds a table of probabilities that we just discussed a moment back. So now come here, take a look at this. Here is Sammy. Okay. Sammy gender features means this is a function we have written. This is last letter, it is taking the last letter Y. And now what do? We'll say classify, which means what do? You take Sammy, you don't give, but you take the features of it and give it the classifier, which is the model. And let's see, it predicts this as female. Sammy sounds like a female. Okay, let's take another one. Let's take somebody from us. Let's take Prasad. Prasad, good job. It predicts as a male. Then let's take Surya. Okay. Surya, female. Okay, let's see if there are females today. Lavanya. Let's see how Lavanya, what Lavanya is predicting as. Lavanya. Lavanya. Female. That's a good one. Doing a good job there. Next, let's say, here is Shakila. Let's see. Everybody's ending with Lavanya, Raghava. Okay, I'm looking for Hemant. Any other girls here? Type in a girl's name, guys, which is not ending with A. Try to use Hillary. Who's this? Hillary and Armila. Armila. Interesting. Okay, let's start with Hillary. Female, good job. Now let's try. Here's Armila, ends with A. Give me any other name. One more name. Lakshmi Kumar, that's a boy. Give me a girl's name. Swati. There you go. Swati is a good one. So let's say, here's Swati. Female. That's doing a pretty good job. So what is this one? It looks like our model is doing a good job. What did we do? Behind the scenes, we prepared our data like this. In real world, what happens, guys? If I do a little bit of cleanup here. We want to get, do a little bit of cleanup here. In real world, the magic lies in this part. How you create your data and give it to the algorithm. You will take 70 to 80% or 80 to 90% of the data in preparing this data. The better you prepare this data, the features here, what is happening is we have only one column, which is the last letter. We are having only one column and we prepared it. This is one scenario. Okay, that is where all the magic lies. Now, for the sake of simplicity, that we have taken 5,000 names and we gave it to the algorithm that gave us a model. But let's test it on the remaining 3,000 names. Let's see, if we give it 3,000 names and say give me the accuracy, what is happening? It is taking testing set which is roughly about 3,000 names and it's giving us an accuracy of 76%. Which means for every 100 names, what it is doing is it is predicting 76 names correctly. 24 names it is not predicting correctly is what is the problem. So now in real world, what do businesses and companies do? They will hire you. And they will say, imagine they hired Prasad and they will say, Prasad, can you do some magic and increase this from 76% to 86% or 96%? Everybody with me, guys? Quick yes, please. Are you catching the point? Okay, so now what Prasad has to do is back here. This is where the magic lies. Imagine Prasad has created this model. He has used this logic. He used this logic and he's getting roughly about 76% accuracy. What they're asking is, can you make it 96% or maybe 90%? Can you bump it up? You need to do some magic. Now, when you look at this, can you think of any ideas, guys? Imagine Prasad built this model with this one. Now they're asking him to increase. Can you think of anything from your side where we can increase our accuracy? Okay. So in other words, there you go. Combination of letters is a good one. Here Prasad used only the last letter. You can take the last letter. You also take the first letter. Put the first letter also. In other words, let's say, do a little bit of cleanup. He just used the last letter. You take the first letter. What you do, you repeat the same process. Okay, let's say this is going to be a dependent variable. What do you do? Well, you take this data, you give it to the algorithm, and what you get, that will give you a new model. Then what you do, use that model for making a prediction, whether somebody is a male or female. Then check it. What is this? Let us say this is Surya. But now, let's say who else we have here. Let's say, oops, one more time, certainly. Come back here. There you go. Let's say, who else we have? Swati. Back to Swati. Now, let's say if Surya used and let's say he got it up to 86%, then what is happening? Surya's model is better than Prasad's model. But now comes Swati. What is she going to do? She is also going to use maybe the middle letter. Oops, let's use this one. She's not only using the first letter, the last letter, but she'll also use a middle letter. And what will she do? Give it to the algorithm. The algorithm will give you a model. And imagine we're getting 96%. Then what do we have? Swati's model is much better than Prasad's model, whose model is better than Surya's model. Everybody catching the point, guys? Can you give me a quick yes? What will happen is, in real world, that is the kind of things that you will be asked to do. You don't have to write a lot of complex programming and things like that. Okay, so now let's come back here and take a look at and see if we can do something. So now take a look at this, guys. If you ask the classifier, show most informative features. I have been explaining that the algorithm is building a table of probabilities. So here is a touch of it. What is happening here is, let's see, here is what is happening. This is how it is building a table of probabilities. It is indicating last letter equals to a female to male ratio is 32 to 1. What does that mean? For every 32 females whose last letter is ending with a, one male, there is one male person whose letter is ending with a. So what is 32 to 1? That is a probability. What is that? This is a table of probabilities that the Naives Bayes algorithm is building behind the scenes. It builds a table of probabilities and then it is extracting these probabilities and using them to make a prediction. Getting an idea, guys? Quick yes, please. Same rows, same 7 rows. Why? No. We have here, I'm just showing you the, whatever is fitting on my screen, Sandeep. Actually, it is using 5,000 names like that. The actual data, if that is what you're asking. Okay. So now let's try to make it a little bit more sophisticated. Imagine Prasad is a data scientist, is working in a company, an iPhone or something like that. And now what they asked him is, Prasad is asked to improve the accuracy. So what we'll do, we are going to create a class out of it. Okay, so here what I'm going to do, I'm going to create a class, and we have used it functionally. In a professional world, we'll build a slightly an object-oriented thing of it. So here's a constructor. Here are all the names we are going to take. Everything is same. We are going to shuffle the names, and then here is where the magic is. So first, let me build the class. Copy this one. Come here. We're converting it into object-oriented, and let's see what's happening here. So here's the class, shuffling it. We have created a static method. Static method is like a complex method. We can call this method without really creating an object. That is what is it. It is like a function is what it is, guys. But I will not talk much about that. So now there's a subtle difference. So earlier, the features that we have built were based on the last letter. Gender features, we were extracting the last letter of each name. Now what we are doing is, if you come here, we are saying gender features complex. What we are going to do is we are going to take a name, we are going to convert it to lowercase. Then now take a look at this. What we are doing is we are extracting the first letter. We are creating a dictionary in which we are creating a key as first letter as the key. Put the first letter. Then take the last letter. Put the last letter. Not only are we taking the first letter, we are also taking the last letter, and then we are using a for loop. What this for loop is going to do is, it is going to loop from A to Z. What it is going to do is, it is going to do something like this. Features of count A, name.count, given a name. Okay, so imagine you have given a name called Sam. What it is going to do is, it is going to take count A. It will pick up A from here, and it will say count A. Is A there in Sam? Yes, it is there. How many times it's there? It's 1. So it will create a column called count A equals to 1. Then it will say has A equals to 2. Then it will take count B equals to 0 because B is not there in Sam. And has B equals to false. And it will keep going from count A has A to count Z has Z. And what is it? These are going to become columns of the independent variables for the sake of simplicity. Okay. Then what are we doing? We're going to call. We're going to send Sam. We're going to extract features of Sam, and we're going to see how that is going to look like. So if you come here, this is what it is. If you give Sam, earlier we just prepared last letter M. Come here, take a look at this. Last letter M is the only independent variable. Now, what do we have? We are also extracting the first letter, we are also extracting the last letter, and for the sake of simplicity, we are starting with count A has A, count B has B. How you prepare your features is up to you. This is where you can use your innovativity, this is where you can use your creativity. That is what is great about this field, guys. It gives you a lot of scope to use your innovativity and creativity. You can play around with as many ideas you have. Okay, what is this? These are all going to become the features, the left hand side. Okay, so now come here, scroll down a little bit, back to the class. What we are going to do is, in our class, here's the names, we're going to shuffle, here are the feature sets. So this is where we are using gender features complex. And what we'll do, we'll partition, we'll split the data. The above that I have done in a functional, we're doing it in a object oriented. When we create an object of this class, all the partitioning is happening, and then we are going to take the 4,000 names this time, and we are going to give it to our algorithm. The algorithm is going to train itself and become a model out of it. Okay, then, so first let me run this one here, and let's start with Sam. Treating Sam as a male for the sake of for sake of discipline, I'm running that. But now if you come back here, static method is what we have just seen. Check gender. What is check gender doing? When you give it a name, it is taking the name, converting it to a lowercase, and then it is saying self classify or classify gender app. So in other words, let me show you here rather than here because the fonts are too big. So here is check gender. You can take any name. So that's what we have done. We have taken Sam here. We're giving it to this function and this method. This method is internally calling the self-classifier.classify, and which is taking the name, extracting the features. Oops, one more time. It's extracting the features, and then calling the classify method, which is where it is asking whether it's a make a prediction, whether it's a male or a female. So now we come back here. Sam is being predicted as male. Let's come back to SOWMY is Soumya, the female. And let's say here is Swati. Swati is now being predicted as male. Let's type in AARON, Aaron. Aaron is being predicted as female. Wrong prediction. Swati came wrong. And let's say, Robert. Okay, Robert is coming as male. That is a good one. Let's take Suri coming in as a female. So, looks like we are getting a few wrong predictions here. And what else we have? Okay, so like that. So now what we can do is we can again verify the accuracy and try to understand whether it is increasing or decreasing. Okay, let's say come back here. So now imagine, guys, a lot of predictions are going wrong. Accuracy, imagine a scenario where our accuracy has reduced. Kranti, let's come back here. Let's try Sandeep because it's ending with P. Say NDEP, Sandeep. Male, okay, that's a good one. But in a scenario, lot of predictions go wrong or our accuracy decreases. Okay, what do you think we can do, or what any idea what could be the problem, guys? You know, what I just explained is to increase the accuracy, we can keep on adding more conditions like this. But imagine our accuracy is decreasing. Okay, if you give, let's say, okay, we can try out with various and things like that. So here is Hari, female. So notice that all the names are going wrong. Okay, instead of asking you, I'll give you the answer, guys. Okay, so what is happening here is the names that we have. Let's say I give you Vishnu, I give you Shankar. These are all Indian names. What we have given to the data that we have is mostly European names and American names. Okay, so what can happen is if you give a lot of names which are Indian names, it may not be able to predict it correctly. So what should you do? You don't need to change the algorithm. You need to give Indian names to it. In the names, in list object which has names, add more Indian names. So what do? As you add more relevant data, what will happen is the algorithm will build a table of probabilities, and that out of the table of probabilities it will be able to give you correct predictions for Indian names also. So your objective is whether you want this model to predict the European names correctly, Arabian names correctly, and Indian names, or is it only for Indian names? What do? Based on that, you have to give it the data. If you're building a model based on the European data and then you're testing it on Indian, that may not be right. If you want to work globally, then you need to give global data. You not only have to give European, American, Arabian names and also the Indian names. So what is it? Data beats the algorithm. You can use any algorithm, but if you are able to give the right data, any algorithm, a simple algorithm is enough for you to build the data. Everybody catching the point, guys? Can you give me a quick yes, please? Okay. Another important thing, guys. Generally, imagine if we did not use machine learning, if we did not use algorithms like this, in a Java or a .NET world, if we want to write a program like this which will predict if somebody is a male or a female, what will you do? You will take a group of names. Let's say you take Hemant. Hemant is ending with H, is a male. Alluri, Jayalakshmi. Jayalakshmi is ending with an I. And what will you do? You will say if the letter is ending with I, it is a male, or is it a female? You will write code like that. But what will happen? Many times, many scenarios will come across where a word is ending with an I. It could be a male or female. In other words, it almost becomes impossible for us to write a program like that. That is where humans fail. What are we doing? That is where we are bringing in the algorithms to our rescue. What are the algorithms doing? Algorithms are using the concepts of mathematics, statistics, and probabilities and allowing us to make a prediction. Everybody catching the point, guys? Okay, now Gentlemen, ladies, here is another important point. We have used this algorithm to predict who's male or female. Okay, in real world, you can exactly use the same concept for taking the data and analyzing a review is a positive or negative. Imagine all the males, instead of male we have positive, instead of female we have negative. Okay, so let's say if I have this one, let's say choose this one, come here, think of female as positive, think of, let's say this was a male here for a moment, oops, and this is positive, and this is male, let us say this is male, and this is negative. Let me do a little bit of cleanup here. So female is positive, and let's say this is male, this is negative. Okay, instead of last letter here, let us say this was a review 1 of Bahubali. Let's say this is review 10 or maybe review 9 of Bahubali. Okay, what is this? Textual data. What do? You can exactly follow the same process. What you will do is you will take textual data, okay, you will tell it what is positive versus what is negative, and then what do you give it to the algorithm. What will algorithm do? Algorithm will give you a model, or from the algorithm will turn into a model. The model will tell you whether something new prediction comes in, whether it is positive, whether it is negative. In other words, what I'm trying to convey is the concept is the same. Okay, the data is different. What are we doing now? We can build a model which will tell us something is a positive review or a negative review. Why is that important? Imagine iPhone released a new feature or a new phone. What is happening is, on a daily basis, millions and millions of customers around the world, they are tweeting, they are chatting, they are writing their reviews in hundreds and hundreds of websites, saying that I'm happy, I'm not happy, and things like that. And what do companies or businesses like iPhone do? They want to understand if their customers are happy or not. And what can you do? Well, if you try to write a program saying that, hey, if a review contains these words, or if it is like this, what will happen? It is almost impossible. What do? That's where we bring in the algorithms to our rescue. Algorithms will help us in making a prediction whether something is positive or negative. Everybody catching it, guys? Can you give me a quick yes, please? So in other words, the data is different, but the concept is same. We can exactly use the same concept for sentimental analysis. The only difference is, instead of male, that is positive, female is negative. Now, imagine the emails, the spam or not spam. What will happen? Well, wherever there is a female, wherever there is a positive, or back here, let's do a little bit of cleanup. We'll call this as a spam. This is a ham. Spam means not a good email, not a genuine email. Ham means a genuine email. What is it? It is the same concept, but what is different? The data is going to be different. The concept is going to be same. You take the data, give it to the algorithm. Oops. See? You're taking the data, giving it to an algorithm, and that will become a model. And now, what's happening? The model, whenever you get a new mail that is predicting whether something is a spam versus something is a ham. Everybody catching it, guys? English names are different to predict sometimes as a male. In Bengali also, yes. So, who's that? Shekhar. So what Shekhar is saying is, sometimes Bengali names might be difficult to predict. What do? So in that case, you need to add more Bengali names. And what will happen? Your algorithm will build a table of probabilities, and you will try to increase that will increase the accuracy. If you think there are going to be Bengali names also. Catching it, Shekhar? Increase the conditions. You can add, yes, increase the conditions. So here, what we have done, guys, I forgot to explain about that one. If we come back here, what we are doing is, we have built, this is our feature set. We're calling them as features. What do? In real world, a company will hire you. And what will they do? They will Imagine you're working for a senior data scientist. He started with something like this. He will tell you, hey, can you think of more innovative ideas? Can you think of more creative ideas than this one? This is like a, just an example. And what will you do? That is where your creativity goes in. That is where your innovativity goes in. You can create as many conditions as you want. And the more creative, what will you do? You can quickly, whenever you come up with a new idea, what do? Well, every day you come up, you sit and you come up with new ideas in your team. And what do? You keep building your model, and you keep checking your accuracy and see if it is increasing or decreasing and things like that. Everybody catching the point, guys? Quick yes, please. Okay? So in a machine learning world, we say data beats algorithm. If you give proper data, your models will give you very, very good. And gentlemen, ladies, here is another important thing. Come back here. This is textual data. In the world of stock data, okay, we talked about sentimental analysis, Bahubali reviews and things like that. Think of this as news headlines. Okay, what happened? Stock price went up. What is this? Let's say Google. Another news headlines, let's say Microsoft or Google went down. Sometimes it's going up based on certain news, sometimes it is going down. What do? You have a lot of textual data based on news headlines, and now what you do? You take all this data, understand when it went up, when it went down, and what do? Give that to an algorithm. What will the algorithm do? The algorithm will become a model, or will give you a model, and now the new model can predict whether, when new headlines are coming, whether a particular stock will go up versus stock will it. Everybody catching it, guys? What can you do? If you are able to collect the right data, what can happen? You can build a very, very powerful model. Gentlemen, ladies, that is where companies are investing lots and lots of money. They're trying to build models based on this textual data, based on these principles. And what are they doing? They're investing millions of dollars, and they're trying to make money. They are not building complex algorithms. They're building the right data. Catching the point, guys? Cool. Okay, so what is this, guys? I explained you 3 to 4 scenarios, but gentlemen, ladies, when you are hired as a data scientist in real world companies and things like that, they are trying tens and tens of such ideas and trying to cater to the needs and things like that to the customers and things like that. There are a lot of possibilities which are possible and things like that. That's what businesses are experimenting. What is the problem? They don't know how to build a feature set. They don't know. They don't have enough people who have an idea how to work with this kind of data. That is where you can go in. With these concepts, with these principles, you can go into the companies, you can explain them, hey, this is what I have done, this is what I can do, and things like that. And that is where they need you, people like you. Okay, guys? Okay. Sheikh exam, will get back to you in about a day or two, buddy. Don't worry about that. Is one type of data same logic need to apply? Okay, so for different kinds of data, same algorithm will be used. Lakshmi Kumar. Okay, so what happens is, how you build your feature set, as I said, depends on your innovativity and creativity. Catching it, Lakshmi? Kumar's question, I see. Oh, sorry about that. Some people are added. Yeah, oh, okay. If you add surnames, again, you have to give the right data. You want to predict a surname, you want to predict the first name. If you want to predict both, add both. If you just want to predict surname, you just give surname. Build your model. Vaishnavi, I think Mansa will get back to you on the exam in a day or two. Okay? Why do we need to normalize our input? Normalize is to remove bias, mathematical bias. Sometimes when you have the variables or features in different units, what will happen is there is a mathematical bias which gets introduced, Pawan. So normalization will remove that at a mathematical level. It brings everything to the same unit. Yes, how to analyze this. So the principles of analyzing real-time streaming data is what we have discussed, Hima. Okay, in real-time data, when news headlines is coming in, that is real-time. You will hook up something you will hook up to the various websites like Twitter and news websites and things like that. Get those real news headlines and you make your model build it. So that is again real time. We need to have use one or two different tools and packages like that is what will happen. Yeah, you can yes, you can also use decision trees, short, but again, when it's categorical data, naive Bayes is works better than any other thing. Shankar. Web scraping, okay. Again, NLP is not used for web scraping, but in NLP you will use web scraping as a part of it. You scrape the websites, news, and things like that, and you try to make quick prediction. And based on your predictions, you can invest in stocks or you can do anything and so on. So, gentlemen, ladies, today is going to be the last session, guys. The objective of this one is to just introduce you to the AI and things like that and get you a feel of it and things like that. So due to time constraints, because we will be, I will not be able to proceed, give you more sessions and things like that, guys. Read passwords, yes, and especially yes. If you train it, Surya, if you give the right data, you can do that, Surya. Short answer. Okay. Okay, I just wanted to give you a touch of supervised learning, unsupervised learning, and because I think in the last 2 or 3 days, a few people requested me NLP, I have covered NLP, guys. Okay, just in case you want to get in touch with me, here's my email. Feel free to let me know. And if you want some more sessions and things like that, Naresh also is giving you free data science and artificial intelligence classes, guys. You can also look at them, Python classes and things like that. You can also log into their website and just find out with them. They are giving you. Yes, I'll be sharing all the thing in our GitHub, guys. I need a day or two to time. Exam. AI, the machine learning, all these topics are related to AI only, guys. To deploy a model. Deploying a model, you can save this model as a pickle, as a Python object, and you can start calling this Python. Uh, um, Run this as a Python script and deploy it. That is the most simplest thing. Wife and husband names, how to predict. Again, that depends on the names, data that you are taking, Lakshman. If you want to predict what is the husband, or you have to prepare your data like that. As simple as that. Oh, Sandeep. Pavan, again, stuff in all this. Yeah, I'll be putting them into GitHub. Online classes, yes, please contact Prithvi, please contact the Naresh IT Technologies for that kind of classes, free classes and things like that. They will give you more information, guys. Oh, accuracy should we get? Okay, generally Surya 70% is good, 80% is very good, 90% or 90% is excellent. There is nothing like you have to get 70, 80, 90. What will happen is, in the first you give a you give a basic model. Maybe you get up to 60 or 70%. You ask the business, you ask your end users to keep using it. Behind the scenes, you keep working with your various techniques and things like that. You keep improving. You take a week's time, 2 weeks, or a month's time. You improve your model to be slightly better, and then redeploy it. That is generally how it goes. And then you take more time, increase it to 90%, keep increasing it. That's what you do behind the scenes. Okay. Was today's session helpful to everybody, guys? Did it give you an idea? Okay. Overall, um, overall, has this last 3 weeks, 4 weeks been helpful to you? Okay. Hopefully that is giving you some motivation. I'm sure our AP skill development will conduct more sessions like this and things like that, guys. Stay tuned with them and try to learn more. Remember, learning is life. And as long as you're willing to learn, I'm sure people, businesses, companies will open up and they will try to reach out to you and get them practice these things and be there, guys. Yeah, today is going to be the last day. In a day or two, Mansa will reach out to all of you and about the exam details and things like that, guys. Okay, she will send you a link where you can take the exam and things like that. Okay. Okay, guys. So for today, I have shared my mail again. I'm going to share it again. That's my email, guys. In case you want to reach out, just give me a little bit of time in responding to you and things like that, guys. No problem. So, guys, I want to wish you all of you good luck, and you guys take care, stay safe, and keep learning, guys. Thank you for all your good comments, positive side of it, and thank you for the opportunity, guys. Friendly suggestion and advice: whether you take machine learning, data science in one institute or another institute, if you're trying for jobs, make sure these skills are there on your resume. I'm telling you, you don't need to be expert. The presence of these skills will make your resume very, very valuable, guys. Make sure you have these skills. You have a touch of machine learning, deep learning, NLP, computer vision, all these things. This is a full-fledged curriculum which cannot be covered in 1 month or so, but you make sure you have these skills and then you apply for jobs. You will have more value, you will have more chances of getting. It is not fair for me to assure you a job or anything like that. That is not in my scope or in my hands, guys. But you have it. If you have batting, you also add bowling to your resume and apply for a cricket team. That is what I'm saying. Don't just go with batting or bowling, is what I'm saying, guys. Okay. So batting is machine learning, bowling is deep learning, computer vision, natural language processing. Have both of them and try it, guys. That would be my sincere advice. Invest a little bit of time, invest a little bit of money if it requires, and you will have very, very good chances. You will feel more confident and things like that. It will be very, very helpful to you. Okay, guys. With that, I will be signing off you guys, signing off for today. I wish you all good luck. Thank you all for your comments and things like that, guys. I will hand it over to Manasa, and
Thank you, sir. Thank you so much.
thank you, Manasa.
It's really our privilege that you have accepted and did this course with APSSDC, and
Thank you,
you have
Manasa.
answered almost every question in the chat box, and you have given very good suggestions to everyone. Thank you so much, sir.
Thank you, Manasa.
It's really a
Appreciate it.
wonderful course. Thank you, sir.
Nice of you. Thank you, Manasa. Okay, I'll be signing off, Manasa.
Thank you, sir.
Thank you. Bye for now.
Uh, Thank you, everyone. So, hope you know that today is the last session, and please everybody fill the feedback form. So based on that, we will be communicating the exam details to those registered mail IDs. In a couple of days, we'll let you know about the exam. Uh, yes, Sandeep will inform resource person to add the NLP code in the GitHub link. Lavanya will let you know about that. Maybe in couple of days you'll be having the exam, so please be prepared. Uh, You'll have the exam like on MCQs, multiple choice questions. We will share the information through mail to your registered mail IDs. So everybody, please fill the feedback form which I have given in the chat box. I'm posting the link again. This exam is based on the classes, the topics which are covered so far. Exam date will let you know. Maybe we'll send a mail 1 day before the exam. Only one attempt is there to complete the exam. We'll let you know the complete details of the exam in the mail itself, about the duration and number of questions, everything like that, and date of the exam, and timing also. We'll send a mail. This question paper will be set by the Naresh IT technology team. So once we get the details, we'll let you know. So based on your attendance and the exam, you will get the certificate. Yes, we will do it through the mail. So I hope everything is clear now. So all the best. And APSSDC is conducting many more programs. So please follow APSSDC website. Thank you all.